All right, let's talk about one of the most important and honestly one of the strangest figures in all of 20th century physics. I'm talking about Paul Dirac. This was a guy who saw the universe through a language that, well, almost nobody else could speak. But it's a language we all ended up relying on.
I mean, think about that for a second. When Albert Einstein is the one saying you're balancing between genius and madness, you know you're playing a totally different game. And that quote, it just perfectly captures the whole paradox of Dirac. His mind was so profound, so almost alien in its logic, that it felt like he was right on the edge of what we even consider sane.
So here's the thing. This guy was a founder of quantum mechanics, right up there with Einstein. His work is the foundation for quantum field theory. He's the one who helped stitch relativity and quantum mechanics together, and he even discovered an entirely new kind of matter. So why on earth isn't he a household name? That's what we're going to dig into. Who was this unbelievably quiet man who completely reshaped how we see the universe?
Okay, so to really get a handle on Dirac the physicist, you first have to meet Dirac the man. And let me tell you, he was something else. His colleague, the famous Niels Bohr, once called him the strangest man he'd ever met. The stories about him, they are absolutely legendary.
So let's just start with this. His colleagues at Cambridge were so blown away by how little he spoke that they actually, and I'm not kidding, invented a new unit of measurement. They called it the Dirac. And a Dirac was 1 word per hour. Yeah, that's how quiet this guy was.
But here's the fascinating part. It wasn't because he was shy. Oh no. It was all about this incredible, almost fanatical precision. You know this quote here? He said this because Niels Bohr was struggling to finish a sentence while writing a paper. For Dirac, it was simple. If you didn't know exactly how the sentence would end, you just shouldn't start it. Every single word had to be perfect, or it was better to just say nothing.
And you can actually trace this back to his childhood. He had this really strict authoritarian father who made him and his siblings speak only French at home. So what happened? Well, Dirac figured if he couldn't say something perfectly in French, it was just easier and safer to stay quiet. And that habit, it stuck with him his entire life.
And this super logical mind was always on. I mean, even in the most normal social situations. There's this great story about him on a ship to Japan with his friend, Werner Heisenberg. Now, Heisenberg was a bit of a ladies' man, always out there dancing. He asked Dirac, "Hey, why don't you dance with the nice girls?" And Dirac's reply is just pure logic. No room for assumptions. It's almost hilariously literal.
Here's another classic story that just sums him up. After one of his lectures, someone in the audience says, "I don't understand the equation on the blackboard," and Dirac just stands there in silence for a long, long time. Finally, the moderator asks him if he's going to answer, and Dirac just says, "That was not a question, it was a comment." See? For him, language was only for precise information exchange. The guy didn't ask a question, so no answer was needed. You can just imagine the room. So that's the kind of mind we're talking about here. Intensely logical, incredibly precise, and unbelievably quiet.
So you have to wonder, right? How does a mind like that even approach something as messy and profound as physics? Well, it turns out he had this guiding philosophy. It was incredibly simple, but it was so powerful it literally unlocked the deepest secrets of the universe. And for him, this wasn't just a principle. It was basically a religion.
And this was it. This was his guiding star. Physical laws should have mathematical beauty. For Dirac, if an equation was elegant, simple, beautiful, then it was probably true. It probably reflected how nature actually works. He trusted the aesthetics of math to guide him to the truth, even when it pointed to things that seemed completely insane.
And he wasn't kidding around with this. This belief went deep. He truly believed that the universe was built on a foundation of profound mathematical elegance. He thought the job of a physicist wasn't to invent things, but to simply uncover the beauty that was already there. And holding on to that belief, well, that's what led to his greatest triumph ever.
All right, so this is where the rubber meets the road. This is where his whole philosophy gets put to the ultimate test. We're in the late 1920s, and Dirac, guided by nothing more than this idea of mathematical beauty, comes up with a single equation. An equation that didn't just describe the electron, it revealed a hidden, mirror image version of reality.
And just look at the timeline here. The speed is just breathtaking. He gets his PhD in 1926. Only 2 years later, he writes down the famous Dirac equation. By 1931, the math in that equation practically forces him to make this wild prediction that antimatter must exist. And then, just 1 year after that, a guy named Carl Anderson actually discovers the positron, the anti-electron, in his experiments. Dirac had literally predicted it into existence using just math.
So what was so special about this one equation? Well, for starters, it did three huge things. First, it finally brought together two giants of physics, Einstein's special relativity and the bizarre new world of quantum mechanics. Second, it naturally explained this mysterious property of electrons called spin, which nobody really understood before. And third, and this is the big one, it predicted that for every single particle out there, there has to be a matching antiparticle.
I mean, just let that sink in for a minute. Dirac didn't find antimatter by running an experiment in a lab. He found it hiding in the pure logic of his beautiful equation. His total faith in mathematical beauty led him to one of the most shocking and important discoveries in all of science. He basically showed us that the universe we can see is only half of the picture.
Now, discovering antimatter would have been enough to put anyone in the history books forever, right? But he didn't stop there. Not even close. Dirac's work is literally woven into the fabric of modern physics. He wasn't just another player on the team, he was one of the architects drawing up the blueprints.
I mean, his work laid the foundation for quantum field theory. That's the theory that describes all the fundamental particles. He's the one who came up with the name quantum electrodynamics, or QED. He even gave us the names for the two basic families of particles, fermions, which are the building blocks of matter, and bosons, the particles that carry forces. And get this, his textbook from 1930 was so good, so clear, that physicists are still using it today.
You don't have to take my word for it. Stephen Hawking himself put Dirac's impact into perspective. He said that in the 20th century, no one did more to change our picture of the universe, except for Einstein. That's the league he's in. Second only to Einstein.
Or, as another physicist, Stanley Deezer, put it even more simply, we all stand on Dirac's shoulders. His work isn't just some historical curiosity. It's the foundation that so much of modern particle physics is built on. Physicists today are still digging into the consequences of the ideas he came up with a century ago.
So it all comes back to where we started, back to Dirac's guiding principle. This deep belief that the universe is fundamentally elegant and that our laws of physics have to reflect that beauty. It's an idea so simple yet so powerful that it allowed this quiet, intensely logical man to predict an entirely new form of matter just by thinking about it. And it leaves us with a really deep question to chew on. If the fundamental laws of the universe really are mathematically beautiful, what does that tell us about the nature of reality itself?